Right. So we are in a special place, special timing. So there should be some people who joined last night, right? I mean last week, Saturday night. So we were on the usual hybrid classroom, and today you are inside my cabin, right? I hope you all can hear me. Can you just raise your hands if you can hear me properly? Great. So let me get the YouTube panel also here because there will be some people who will be joining the live stream. So let me keep it on the other side. So let me get the YouTube panel also here. Right. So we are going to talk about pure mathematics, right? There is also specifically in advanced level, English medium mathematics or local, right? So when it comes to this subject, many people tell that this is a very difficult subject, and sometimes it is said to be that it's the most difficult subject in the Sri Lankan syllabuses, right? But I don't know up to which extent you believe that fact. But I mean, I'm thinking that this is not that difficult, right? Not that difficult. But when you compare to the opinions of the majority, they would say that this is difficult, right? And why is that? How is that difficult? So let's talk about it. And last week, I did a very small session on limits, and I realized that many students from different layers like 2025, 2024, and also 2023 are on the same understanding, right? I mean, there are small differences, but I mean, what I can see is that they all are performing really good, right? So, which is a proof that anyone can actually learn this. There's no age barrier. It's a matter of focusing onto the topic, right, and understanding the concept, right? And this particular session is going to be purely on pure mathematics. And I would say pure mathematics is the art piece of mathematics. The most beautiful area in mathematics is pure mathematics. But it doesn't mean that applied mathematics is not good. That is also good in a different manner. That is more dedicated towards applications where you derive the pure mathematics into a different architecture where you can see practical applications of that. And which doesn't mean that pure mathematics is not having any such practicality in the world. It is also having, right? But that's a different color, right? So I like that color better, I guess. I mean, I like that more than I like applied mathematics. But however, since it's a free session that I'm going to continue, right? I don't think that anyone will have a trouble in that because I'll be focusing on pure mathematics. And after some time, after learning some pure mathematics, we'll talk about what we can do on applied mathematics. Right? Maybe it's going to be much easier when you know proper pure, right? So let's think about this particular idea in a contrast manner, right? If you go to the advanced level, combined maths paper, let me show you. The combined maths paper consists of two different elements, right? One is the pure mathematics part, and the other one is applied mathematics, right? So, pure mathematics paper will give you 1,000 marks. Yeah. Where applied mathematics paper will also give you 1,000 marks, which means you have altogether 2,000 marks. Okay. And simply when you divide this by 20, yeah, you get the 100. Okay. The usual numbers are 75, 65, 55, and 45 for the grades A, B, C, and S. Right. So I'm pretty sure that all of you are expecting to get this grade, right? But fortunately or unfortunately, in Sri Lanka, the people who are getting into this grade is very less because they cram questions, especially in this examination we had. I mean, a few days back, we understood that the people who can remember, the questions they have done have failed. I mean, like, the memory is not going to be helpful. But I mean, we cannot say that memory is not useful as well. If you have a proper discipline towards the concepts, you will love them, right? So then memory becomes permanent. So you don't have to worry about memorizing, right? And the other thing, when you understand the concept to the deep contrast, things are going to be much more clear, right? Much more clear. Things will be very simple, right? So if it is simple, it's not going to be a difficult task for you guys. Right? So what I'm trying to do here is get the original sounds on for you. But I think as long as the sounds are clear to you, I'm all right. Okay. How many of you want to know what is the exact content of pure mathematics in advanced level? Can you raise your hands? What is this like? What are we going to do with pure mathematics? Hasid, Bilal. And by the way, I think since you guys were there last week, it's better if you can turn on the video devices so that things will be much more clear and we can communicate. Yes, right? Very good. Okay, that was Khalidu. Thank you, Khalidu. And if others also can join in this contrast manner, that will be awesome, right? So when it comes to pure mathematics, it's a matter of understanding the abstract of the real world. So what is abstract? So let's try to learn the word. So there will be some terms that you will need to learn in order to understand the full journey. One is abstract. Abstract. What is abstract? Abstraction is something you can only have in your mind. It is not in the real world. Right? We can even use the term hypothetical for that, but hypothetical is a little bit different because there you suggest things. But abstraction is purely a mind product. Let me tell you a very simple example. Okay. Now, if we take an example number 1. Okay. Now, this is number 1. But if someone questions what is 1, we have a problem. Because this is one way of representing the concept called 1. One way of representing. But there are other representations for 1 as well. Let's say you can have Roman number 1. You can have Arabic number 1. And I mean so many. So basically this is also 1. This is also 1. This is also 1. But the real concept 1 cannot be written like this. Listen, you can find 1 bottle, 2 bottles, 3 bottles, 2 cars, 5 cars, but you cannot find these 5, 2, because it is not existing in the real world, isn't it? So all the numbers we know so far, all the numbers from grade 1 are not existing in the real world. It's in our mind, right? So we use some symbol to represent it, right? So let me tell you a nice story. Imagine 2 friends are looking at the star and one person is telling, okay, I can see 3 stars. Okay. Imagine the other friend doesn't know what is 3. Okay. Oh, they have understood 3 as a different number, right? Let's say the word 3 is given for 5. Imagine. So then their communication will have a huge gap, right? A gap of 2 numbers. So basically it's all about defining, right? So we have defined, prior to the learning that this is 1. This symbol is 1. So you believe a lie, which is not exactly there, but I mean that becomes a theoretical. And then onwards, you use that model to analyze other things. So you're trying to find 1 and 2 and 3, those numbers in other things that we see on our daily life, right? So then we start using those words in our language. Right? I need, a cup of tea means that means 1 cup of tea, right? So you start giving meanings to that. So basically, if you understand pure mathematical content, and once again, it will come to the concept called abstraction. Numbers are vital, but these numbers are actually taken into the consideration in a way such that it is not existing in the real world, but only in your mind. Imagine this geometry, right, in mathematics. So these rectangles, circles, I mean, you can draw, right? You can draw a circle, but it has a thickness, right? It has a small thickness. So we can even tell that this is a solid, it is not a circle, right? So circles are also not existing in the real world, even a square, rectangle, whatever, any shape. So numbers, geometric shapes, all these things are not existing in the real world. Are we clear? Right? So with these non-existing things, we can actually understand existing things. Same for the unknowns, right? Same for the unknowns. Like algebraic terms, that is also not existing in the real world, right? So with these kind of elements, how the national syllabus is treating us. So this is what we need to learn, right? How the advanced level combined mathematics is treating us, right? If you think of that particular scenario, it's a nice journey, right? So let's start that journey and see what we have to learn, right? So look at this. So I'm going to keep a limit here, right? So that we all can see. I'm going to use a very small space, right? So look at this. So we have algebra. Then we have trigonometry. This is like the baseline, the heart of the syllabus. I'm like, we need both of them for sure, right? And then we have calculus, then coordinate geometry, right? Then we have summation of series with combinatorics. And then we have a very nice application once again. After all these 3 formats, it's going to be different variation, that is matrices and elements. Matrices and determinants. Right? And good news is, other than for calculus, coordinate geometry, summation of series, and also matrices, we will need algebra and trigonometry. Right? So if you notice, in the whole pure syllabus, you are learning only 3 things, right? Which is all close within these 3 things, right? Number 1 is algebra. Then we have trigonometry. And then we have calculus. This is the core of pure mathematics. Only 3 pillars. Only 3 pillars. Out of these 3 pillars, we will see subsections. Now, this is the scenario, right? Now, if you look at these 3 pillars, right? One is algebra, trigonometry, and calculus, right? You tell me, from which area you think you should enter the stream? Is it going to be algebra, trigonometry, or calculus? What do you think? So let me go down to the usual classroom, right? Until that, you can find an answer to your question, right? And I'll be starting with one of these chapters, right? And let's see what we can learn there. All right. So let me catch you downstairs. I'm going to turn on the video here. I hope that you all are prepared. So have a book with you, right? Separate new paper, right? If it is the last, night's book you are using, keep a new page open because we will learn something new today. And so let me turn off the video here and come back from the usual classroom. All right. පොඩි දෙයක් කන්න තිබ්බත් හොඳයි. ලොකු එකක් ආව පොඩි චූරි දෙයක් සෑන්ඩ්විච් එකක් වගේ තිබුණා. අර ස්පොට්ලයිට් එක අයින් කරන්න. හරිනේ. මයික් එකේ. Okay. Hope you all can hear me, right? So we were talking about three pillars: algebra, trigonometry, and calculus, right? So let's see how the other lessons and the questions are placed. For an example, I would say this algebra question is purely based on algebra. So we call this question number 11, right? That is the first paper, part B. Then trigonometry will be the last question. That is 17th question, right? And calculus, you will have two questions. That is 14th question and the 15th question. 14th and the 15th, right? And I would place coordinate geometry
in between algebra and trigonometry, because that's a composition of both in the Cartesian coordinate space. And that becomes the 16th question, right? So if we notice now we have 11, not 12, not 13, but 14, 15, 16, 17. So what is this 12th question and 13th question doing here? So let me show you. There's a specific area called complex numbers. Complex numbers. Right? And a specific area called matrices. Right? So these two would consist of one question, that is question number 12. And then we have the summation of series, mathematical induction, and finally, permutations and combinations. Permutations and combination. And this will set up the question number 13 for us. You see, very simple. So you can see there are altogether 7 questions here, right? Out of the 7 questions, you will have to answer only 5 questions. Each question will give you 150 marks. That means at a maximum, you can get 750 marks, right? 50 marks. Then you would wonder where the hell is the remaining 250, right? Because that is very simple. So you'll have 10 short questions, 10 short questions. That will give 25 marks each to give you 250 as a final count, right? So this 250 along with this 750, you get altogether the 1000 mark we are talking, right? So let's be very simple and understand it is about working out 15 questions in 3 hours for the exam, right? So you have 3 hours. So you have 3 hours. You have 3 hours. And then you have 6 minutes into 10 for the first 10 questions. So that is 60 minutes, 1 hour. Then 24 minutes per question, such that you have 5 questions, and that is 2 hours. So altogether, we have 3-hour paper, right? So which means you can leave out 2 questions out of this 7, right? So this is the game board, right? So you need to know how to play the game first of all, right? In the examination paper, it's a matter of answering 10 short questions and 5 main questions out of these 7 topics, right? So if you notice, it is very simple, right? Because you know the topic, you know the question area, and you will know the theory content as well. But then why people are telling this is difficult? Because one person can do infinite number of questions under algebra, but it doesn't guarantee that that question will appear on the examination. Are we clear? So there's no guarantee that it will appear on the examination the same question that you have done. Because I have noticed many students, when they get into a math question, the very first thing that they are thinking is like, have I seen this question before? Have I done this before? Right? And that is a wrong way of thinking. So that is what I'm trying to tell you. That is not the way to look at mathematical questions or problem solving process. Instead, we have to be very natural and think from the beginning, right? Think from the first point, what is happening here? Are we clear? Right? So that is our target. So our target is to understand this from the base, so that you will become smart kids rather than nerd kids, right? Okay. So let's think about this concept in a different, environment. If you want to get a note, you can have a small short note on this. So this is note number 1. You can get a small note on your book, okay? I'll give you 1 minute. So get a small note in any way you like. ඔගොල්ලෝ කැමති විදිහට note එක දාගන්න. No problem. So there's no restriction. At least you know how to play the game. Bilal, good morning. Hasit, good morning. Rachita, good morning. Yasiru, Kalindu, good morning. You can easily turn on your mic and say good morning at least, so that I know that you guys are there, right? Just turn on the mic. Yes. So let's get together, right? This is not a game where you listen and I work. It's a game where we collaborate. We get together and learn. So that is the spirit of it, right? Please get the note, right? Get a small note, what is on the board. And if you have any questions, now you can ask. If you have any type of questions in your mind about this particular proceeding, you can now ask. Alan, do you have any questions about the style of the paper? Any questions? Anyone else have any questions? You can even put it on chat. Any other question you have about this shape? Because now we are going to analyze the shape of the paper in a different manner in a minute. Okay, so Kalindi is asking, so is this only from the pure maths area? Yes. So I'm talking about the pure maths, divisions, because our class is focusing on pure mathematics. Any other questions? Any other questions? If you have any other question, you can further ask them. Since the silence, I guess there's no question coming up in terms of this format. So let me erase this. So since I already said that there are 3, shapes of, concepts. Let me talk about one type of concepts and its feeling, right? Imagine you have x plus y whole thing square. Focus and think clearly. Don't think about anything else, okay? X plus y whole thing square is simply x plus y multiplied by x plus y. Now this may look like grade 9 mathematics for you, but let's focus. So x times x is going to be x squared plus x times y is xy plus y times x is also xy as a culture, as a ritual in a culture. In mathematics, we always use the alphabetical order when we write two letters in English. That is why I use xy. It is not written in the order of multiplication because x times y and y times x are the same. There's no difference, right? And finally, y squared. And when you look at this, you can see that it can be further simplified in order to get x squared plus 2xy plus y squared, right? So now you can clearly see, this is a new shape that follows. If you have a triangle, plus a circle, triangle plus a circle, whole thing squared should give you a triangle squared plus 2 times a triangle times a circle, right? Plus a circle squared, right? Now this is called a shape, or this is like a feeling. And this is a complete square, right? That is first entry squared plus 2 times multiple of the two entries plus the square of the final entry, right? So if I write alpha plus beta, whole thing squared, that is going to be alpha squared plus 2 alpha beta plus beta squared. Clear? That is alpha squared plus 2 alpha beta plus beta squared, right? So let's write this as concept number 1. Concept number 1. Concept number 1. Right? This is concept number 1. Shall we get this down? Quickly get this down. Like it won't take much time. So first you listen, focus, and get the note down. Think that this getting down the note part is where you take them to the mind and keep them forever. So you are going to keep it in your permanent memory, right? So that you don't have to recall again. When you see them, you feel it, right? Concept number 1. Concept number 1. Concept number 1. Lasan dagan wala. Concept number 1. Concept number 1. And we will work out few examples, okay, using this shape. So I hope that is in your book by now, right? Because that is not a very difficult thing to understand, and this is something you already know, right? Now I'm going to play with this shape, okay? So let's try 2x plus y whole thing square. So this is first term squared, that is 2x whole thing squared plus 2 times 2x multiplied by y plus the final term, and which is 4x squared plus 2 times 2 is 4. So 4xy plus y square. There you go. So this is our example. Right? So write that down as an example. So this is an example. Okay. So I'm going to give you 3 questions to do very fast and WhatsApp me on note 7 67 57 5783. Let's see who's the fastest here. Okay, fastest. I want to find the fastest person, right? So we have 2x minus 3y whole thing squared. Quickly do all 3. Next one is 1 minus x over 2 whole thing squared. Number 3, x plus y plus 1 whole thing squared. Okay, do it very fast, and I'm going to publish the name of the fastest person here with the correct answer. Let's do it quickly. So time ticks now. Now it's exactly 9:27. Okay. Let's see how many minutes you will take to complete all 3. And when you send it to WhatsApp, then only I will know that you are all done. Take your time and do it nicely. I'm waiting for the first answer. So I'm waiting for the first answer. So if you are fast enough, you can work them out quickly. Okay, send me one by one. If you are done with number one, send number one. When you are done with number two, send number two. When you are done with number three, send number three. So I can see who's at least completing the very first one fastest. Right? Ivan Balan. Okay, we have two answers at the same time. So one is, I don't know how that happened. This is exactly spot on. Okay, third one is also at the same time. So we got the first answer at 9:31. Okay, that is also 9:31. So we have answers coming at 9:31. That is 4 minutes later to this particular show. So we have these people. We have Rachita. We have Rachita. We have Rashmi. Okay, she has deleted. Right, so we can't get her there. So we have Kavindu. And we have Bilal. So Bilal and Rachita, they are 24 A-level students. And Ravindu is a 25 A-level student. So very good. So that is really good. But now let's work out all three and see whether you all are correct. Okay. So let's work them out in a very simple manner. See what I'm going to do. This is 2x plus minus 3y all things squared, right? So this is equal to first term squared, that is 4x squared, plus 2 times the two terms, that is 2x times minus 3y. And finally, when you square it, anyway, it's going to be 9y squared. So you get 4x squared, 2 times 2 is 4, 4 times 3 is 12, that is minus 12 xy plus 9y squared. See how simple that is? Then we have 1 plus minus half times x, okay, and whole thing squared. So first term square, 1 square is 1, plus 2 times the first term times the second term, that is minus half of x, plus 1/4 of x squared. So which is 2 times half cancels, 1 minus x, 1 minus x, plus x squared over 4, right? And finally, we have third one, x plus y plus 1 whole thing squared. So I can write this is x plus y plus 1 whole thing squared. So now I can see only two terms. See? So x squared is the first term square plus 2 times the first term times the second term plus the final term squared. So this is x squared plus 2 times xy plus x when you open the brackets plus first term squared, that is y squared, plus 2 times y plus y times 1 is 2y plus 1 squared. So now we can further simplify. This is x squared plus 2 times x times y, that is 2xy, plus another 2x, and plus we have 2y, plus y squared, 1 squared is 1x, and this is the final list. So if you haven't got the correct answers for all three, please get this down quickly. Right, so we have number 1 here, number 2 here, and finally number 3 here. Are we clear? So get them down quickly. So I'm trying to make this as simple as possible, so for anyone can understand, right? We don't need a specific knowledge for these kind of simplifications, right? We don't need a specific knowledge. A very general knowledge would do, right? Can you raise your hands if you have got all three correct? The people who have got all three correct? Okay, 2 questions correct. 2. Okay, so you had 2 of them. Only 1 correct, only 1. Only 1 is correct. Okay, good. Now, do you all understand the answers? Okay, raise your hands, those who understand this. Okay, I couldn't do it correct, but now I understand. And also the people who has done it and also understand it now. Yasiru? Cool. So 1, 2, 3, 4, 5. All can understand. So that is good. All can understand. Or get the note quickly. We will move to the next round. Okay. So if you have x plus y, whole thing squared, now we recognize this is x squared plus 2xy plus y squared, right? So what if I decide to take this 2xy to this side? Then you get a new shape, that is x plus y whole thing squared minus 2xy will have you only the square of x plus the square of y. So if you notice, this is another way of writing sum of squares, sum of squares. So which means by observing this, if you have a triangle squared plus a circle squared, right, that should be equivalent to triangle plus a circle whole thing squared minus 2 times triangle times circle. We can consider this also as a shape. So write down this and then the subtopic sum of squares. Quickly, sum of squares. Sum of squares. Quickly get down. And when you're done with that, please work out the following. Okay. Find alpha squared plus beta squared. How I'm going to use the following shape to manipulate this. Then 2x, sorry, all right, 4x squared plus 9 equals using this format. Then we have x divided by 9, sorry, x squared divided by 9 minus, let's say, 81 equals. So these are the three questions for you. Once again, when you are done with it, WhatsApp, I'll find the fastest. Note 767 5757 83. Quickly, right? Do it quickly. I want to find the fastest. Good. I'm waiting for the first answer. Let's do it. Analyze the shape. That's it. Very good, we have two answers. So we have three answers now. Four answers. Very good. So let me work them out. Let's go one by one. So this is alpha plus beta whole thing squared minus 2 times alpha beta. So this is same as 2x whole thing squared plus 3 squared. So which is 2x plus 3 whole thing squared minus 2 times this, that is 12x. 2 times 2 is 4, 4 times 3 is 12. Final one, this is same as x over 3 whole thing squared minus 81. So minus 3 square. 9 square, sir. Guys, don't do mistakes. This is your all levels. This is difference of 2 square. That is x over 3 minus 9 times x over 3 plus 9. Okay. Very important. You can see this is not the same caliber. This is sum of squares. Sum of squares. This is difference of squares. Hands up who realize that this is not in the shape. People who realize that this is not in the shape. People who understood that these two and this one are different. So get them down. So this shape is called difference of 2 square. So let me now brief it as well. So a squared minus b square is given by a minus b times a plus b. You can simply bracket them out to see the left hand side. Which means if we have a triangle squared minus a circle squared is turning out to be triangle minus a circle times a triangle plus a circle. A triangle plus a circle. Are we clear? Right. Okay. So if you have got this down, I'm going to brief these three concepts now. Okay. Write down brief. So write down brief. 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 So you may write, this is going to be number one shape, that is x plus y whole thing square. So that is a complete square. This is given by x squared plus 2xy plus y squared. Shape number two. We have x squared plus y squared. This is derived from this one, right? Which is x plus y whole thing squared minus 2xy, right? And the third shape is something we already know, that is x squared minus y squared is a complete factorization as well, that is x minus y times x plus y. So get this down, brief, quickly, get this down. This is the brief. Get it down quickly. YouTube live ke then stop karan. Yeah, you can do it from here.